Welcome to Math with Mr. J. In this video, I'm going to cover how to calculate probability. We will start with two basic probability examples that we will go through step by step. Then we will take a look at some probability examples using playing cards and then a die. And then lastly, you will try some practice problems on your own. So we will have four sections here: intro examples, playing cards, a die, and practice problems. Now, simply put, probability tells us how likely something is to happen. In other words, the chance of something happening. Not all things in life are sure things. We can't predict everything with 100% certainty, meaning we may not know what's going to happen. So when we are unsure about the outcome, the result of something, we can use probability to help us understand how likely something is to happen. For example, if we flip a coin, it can be heads or tails. We can't predict with 100% certainty. We don't know for sure, but we can use probability to tell us how likely a certain outcome, a certain result, will be. Let's jump into number one, where we have a spinner. And we need to figure out what's the probability that we spin this spinner once and we land on 3. Well, let's break this down, and we'll start with the probability formula, which is right here. We have P for probability, and then in parentheses we have the word event. And an event is whatever we are finding the probability of. Basically, an event can be one or more outcomes that we are interested in and focused on. The probability of an event equals the number of favorable outcomes over the total number of possible outcomes. Favorable outcomes are all of the ways our event can happen. Then the total number of possible outcomes, that's the total number of things that can happen. The total number of possibilities. All of this will start coming together as we go through our examples. Let's start with the number of favorable outcomes we have. How many ways can our event of spinning a 3 happen? So we need the number of sections on the spinner with a 3. Well, there's one. We have one favorable outcome on that spinner. One way that our event can happen. So favorable outcomes, 1. Next, we have how many total possible outcomes do we have? So how many total sections can the spinner possibly land on? Well, there's section 1, 2, 3, and 4. There are 4 equal-sized sections that the spinner can land on. So each section has an equal chance of being landed on. So again, there are 4 total possibilities. Now let's use this information to write out the probability, which we are going to write as a fraction, decimal, and percent. So we have P for probability, and now we need our event in parentheses. That's landing on a 3. So let's put a 3 equals, well, we need the number of favorable outcomes, 1, over the total number of possible outcomes, 4. That's our fraction, 1 over 4, 1/4. And that's our probability. We have a 1 out of 4 chance of spinning a 3. Now let's write that as a decimal and a percent. 1/4 as a decimal is 0.25, 25 hundredths. Remember, divide the numerator, the top number, by the denominator, the bottom number, to go from a fraction to a decimal. And then as far as the percent, we get that percent by multiplying the decimal by 100, which a quick way to do that is move the decimal twice to the right. So our percent is 25%. And this is the probability that we spin this spinner once and land on 3. This describes our chances. This helps us understand how likely it is that we spin a 3. We actually have less than a 50% chance here. One section out of 4 has a 3, and that's up against 3 other sections that have other numbers. The probability of spinning a 3 here is more unlikely than likely. We have a higher probability, a better chance, the spinner lands on one of the other numbers. So we call this an unlikely event. Now, with that being said, can we still land on a 3? Absolutely. I'm not saying we can't. We're just thinking about the likelihood that we do. So this is something to start thinking about, what the probability is telling us. Let's move on to number 2. Taking a look at number 2, we have what's the probability of picking a red marble? So let's say we have all of these marbles in a bowl and we randomly select one without looking. So each marble has an equal chance of being selected. What's the probability we pick a red marble? Well, as far as our favorable outcomes, we could pick red marble number 1, 2, 3, 4, 5, 6, or 7. So there are 7 red marbles. That means we have 7 favorable outcomes, 7 ways that we can end up picking a red marble. Now we need the total number of possible outcomes. So the total number of marbles. Well, we have 1 green marble, 2 green marbles, and then 1 blue marble. So 7 red marbles plus those other 3 marbles gives us a total of 10 marbles. So we have the probability, and then our event is picking a red marble. So we will put red here, equals the number of favorable outcomes, that's 7, over the number of total possible outcomes. That's 10. So we get 7 over 10, 7/10. That's our fraction. We have a 7 out of 10 chance of picking red. Now let's write this as a decimal and percent. 7/10 as a decimal is 0.7, so 7/10. Now remember, divide the numerator by the denominator to go from a fraction to a decimal. And then as far as our percent, we multiply that decimal by 100. A quick way to do that is to move the decimal twice to the right. Our percent here is 70%. So this is the probability of picking a red marble. This describes our chances. This helps us understand how likely we are to randomly pick a red marble. So thinking about our chances here, we have more than a 50% chance of picking red. We have 7 red marbles out of the 10 up against 3 marbles out of the 10 that are not red. Our event of picking red is more likely to happen than unlikely. We have a higher probability of picking red, a better chance of picking red, than picking another color. We call this a likely event. So there's our 2 introductory examples. Let's move on to our second section. Here are our next probability examples. Let's jump into these examples where we are going to say that the playing cards are face down on a table, so we cannot see what they are. We're going to randomly select one, so each card has an equal chance of being selected. We have 5 events here that we are going to find the probability of. Let's start with number 1, where we have the probability of picking a 9. So picking a 9 is our event. If we randomly pick one card, what's the probability we pick a 9? And we're going to write the probability as a fraction, decimal, and percent. Let's start with the number of favorable outcomes. So how many ways can this event happen? How many cards have a 9? So looking at the cards, we can see 1. One card has a 9. So our numerator is 1. Now we need the total number of possible outcomes, the total number of things that can happen. So how many possibilities do we have here? How many cards are there? 5. So 5 is our total number of possible outcomes. So 5 is our denominator. We can pick any one of those 5 cards. So we have 5 possible outcomes, 5 possible results. that's our fraction, 1 over 5, 1/5. And that's our probability. We have a 1 out of 5 chance of picking a 9. Now let's write that as a decimal and a percent. 1/5 as a decimal equals 0.2, 2/10. Remember, divide the numerator, the top number, by the denominator, the bottom number, to go from a fraction to a decimal. And then we can get our percent by multiplying the decimal by 100, which a quick way to do that is move the decimal twice to the right. So our percent here is 20%. So this is the probability of picking a 9. This describes our chances. This helps us understand how likely it is to happen. Let's move on to number 2, where we have, what's the probability of picking an odd number? Let's start with the number of favorable outcomes. So how many cards have an odd number? We have a 7, a 5, a 9, a 7, and a 3. So all 5 cards. We have 5 favorable outcomes. So 5 is our numerator. Then our total number of possible outcomes is 5 as well. There are 5 total cards. So our denominator is 5. And that's our fraction, 5 over 5, 5/5. We have a 5 out of 5 chance of picking an odd number. Now let's divide the numerator by the denominator to get our decimal. That's going to be 1 whole. Keep in mind, whenever we have the same number on the top and bottom, our decimal is just 1. Now, since this is a whole number, we typically don't write the decimal point. But remember, a decimal point comes after a whole number, after the ones place. Then our percent here, we multiply that decimal by 100, and that's going to be 100%. 5 out of 5 cards have an odd number, so we have a 100% chance. This is what we call a certain event. We're 100% certain it will happen. Let's move on to number 3. What's the probability of picking a card with hearts? Favorable outcomes? Well, there are 3 cards with hearts. So we have 3 favorable outcomes. That's our numerator. And as far as the total number of possible outcomes, that's 5. There are 5 total cards. So our fraction is 3 over 5, 3/5. We have a 3 out of 5 chance of picking hearts. As far as our decimal here, 3 divided by 5 gives us 0.6, 6/10. Then we can multiply that decimal by 100 to get our percent. Our percent here is 60%. And that's our probability of picking hearts. Moving on to number 4, we have, what's the probability of picking a queen? Favorable outcomes here? Well, it looks like we don't have any queens at all. So this is going to be 0. We have 0 favorable outcomes. There aren't any ways that this event can happen. And then our total number of possible outcomes is 5. There are 5 cards in total. And that's our fraction, 0 over 5, 0/5. We have a 0 out of 5 chance of picking a queen. Then as far as our decimal, that's going to be 0. And our percent is going to be 0%. We have no chance of picking a queen. This is what we call an impossible event. Lastly, let's move on to number 5, where we have, what's the probability of picking a 3 or a 5? So think, if we randomly pick one card, we want either a 3 or a 5. As far as favorable outcomes, how many cards have a 3 or a 5? We have 1 3 and 1 5. So that gives us 2 favorable outcomes over the total number of possible outcomes, 5. Our fraction, 2 over 5, 2/5. We have a 2 out of 5 chance of picking a 3 or a 5. There are two cards that we can pick here that will make our event happen. Either will work, picking the 5 card or picking the 3 card. Now for the decimal, 2 divided by 5 gives us 0.4, 4/10. And then multiplying that decimal by 100 gives us our percent, 40%. And that's our probability of picking a 3 or a 5. So there's our second section on calculating probability. Let's move on to our third. Here's our third section where we are going to use a die. Let's jump into our examples here where we are going to say that we are rolling a fair 6-sided die. And a fair die just means we have an equal chance of rolling any of the sides. We have 5 events here that we're going to find the probability of. For number 1, we have what's the probability of rolling a 4? So if we roll the die once, what's the probability we roll a 4? So the 4 is facing up. Well, let's write the probability as a fraction, decimal, and percent. Let's start with the favorable outcomes. So how many ways can this event happen? How many sides have a 4? And you'll notice we have all of the possible outcomes right here. Those are all of the sides of a 6-sided die laid out. One side has a 4, so we have one favorable outcome. Now we need the total number of possible outcomes, the total number of things that can happen. So how many possibilities do we have here? How many sides does the die have? Well, 6. Our fraction, 1/6, 1/6. We have a 1 out of 6 chance of rolling a 4. Now, as far as the decimal, we can divide the numerator by the denominator, so the top divided by the bottom, to convert this fraction to a decimal. That's going to be 0.1, and then we have a repeating 6. So this is a repeating decimal. Now we can convert the decimal to a percent by multiplying the decimal by 100. And a quick way to do that is move the decimal twice to the right. So our percent here is 16.6 repeating percent. Now we can leave the percent like that or round. Let's round this to the nearest percent as well, which is rounding to the ones place. We have a 6 in the ones place with a 6 to the right in the tenths. So this rounds to 17%. So this is approximately, and I'm using the approximately symbol here because we are rounding, 17%. And that's the probability of rolling a 4. Let's move on to number 2, where we have what's the probability of rolling an even number? So if we roll the die once, what's the probability we roll an even number? Let's start with the favorable outcomes. So out of the 6 sides of the die, how many are even numbers? Well, we have 2, 4, and 6. So 3 even numbers. So 3 is the number of favorable outcomes over the total number of possible outcomes, which is 6. So our fraction here, 3/6, 3/6. There's a 3 out of 6 chance of rolling an even number. Now I do want to mention 3/6 can be simplified. So depending on your situation, your class, the directions, whatever the case may be, you may be asked to simplify. 3 and 6 have a common factor of 3 that we can divide 3 and 6 by. 3 divided by 3 is 1, and 6 divided by 3 is 2. So this simplifies to 1/2. So either of those will work. Next, we need our decimal, and we can go from either of those fractions. We get the same thing either way. We get 0.5, 5/10. Then we can multiply that by 100 to get our percent. Our percent here, 50%. And that's our probability of rolling an even number. Moving on to number 3, we have what's the probability of rolling a 5 or 6? Both of these are a favorable outcome. Both of these will work. We either want to roll a 5 or a 6. Think of it like this: you need to roll a 5 or a 6 to win a game. So, what are your chances of rolling a 5 or a 6? What's the probability? One side of the die has a 5 and one side of the die has a 6. So that gives us two favorable outcomes here. So 2 over the total number of possible outcomes, 6. So our fraction here, 2 over 6, 2/6. Now, this fraction can be simplified. We have a common factor of 2 that we can divide 2 and 6 by in order to simplify here. 2 divided by 2 is 1, and 6 divided by 2 is 3. So this simplifies to 1/3. So either of those fractions here will work. Now let's convert this to a decimal. And our decimal here is going to be 0.3 repeating. So this is another repeating decimal. Let's convert this to a percent. We have 33.3 repeating percent. Or we can round this to the nearest percent, which again is rounding to the ones place. We have a 3 in the ones place with a 3 to the right in the tenths. So this is approximately, this rounds to 33%. And that's the probability of rolling a 5 or 6. Next, moving on to number 4, what's the probability of not rolling a 1? So our favorable outcomes here, we want anything but 1. So all of the numbers except 1. So 2, 3, 4, 5, and 6. That gives us 5 favorable outcomes, and that's over 6, which is the total number of possible outcomes. So 5 over 6 here, 5/6. We have a 5 out of 6 chance of not rolling a 1. So again, we're looking for anything but 1 here: 2, 3, 4, 5, or 6. Now let's convert this to a decimal. We get 0.8 and then a repeating 3. So another repeating decimal. And then let's convert this to a percent. We get 83.3 repeating percent. And let's round this to the nearest percent as well. We have a 3 in the ones place with a 3 to the right in the tenths. So this is approximately, this rounds to 83%. So that's the probability of not rolling a 1. And lastly, let's move on to number 5, where we have what's the probability of rolling a number greater than 2? So we have 3, 4, 5, and 6. That gives us 4 favorable outcomes here. So we have 4 favorable outcomes over 6, the total number of possible outcomes. So our fraction here, 4 over 6, 4/6. We have a 4 out of 6 chance of rolling a number greater than 2. Now this fraction can be simplified. We have a common factor of 2 that we can divide 4 and 6 by in order to simplify. 4 divided by 2 is 2, and 6 divided by 2 is 3. This simplifies to 2/3. So either of these fractions will work. Now let's convert this to a decimal. We get 0.6 repeating. And let's convert this to a percent. We get 66.6 repeating percent. Now let's round this to the nearest percent as well. We have a 6 in the ones place with a 6 to the right in the tenths. So this is approximately, this rounds to 67%. And that's our probability of rolling a number greater than 2. So now that we've gone through some examples together, it's time for you to try some practice problems on your own. So have paper and a pencil ready. Here are your practice problems. Calculate the probability of these 6 events. Numbers 1 and 2 will use the cards. Numbers 3 and 4 will use the spinner. And numbers 5 and 6 will use the marbles. Write each probability as a fraction, decimal, and percent. I'll give you 5 minutes to work, and then we will go over the answers. Go ahead and start. Okay, so that's 5 minutes. Let's go over the answers. Here are our answers. For number 1, our fraction, 7 over 10. Our decimal, 0.7, and then our percent, 70%. For number 2, our fraction, 4 over 10, which can be simplified to 2 over 5. Either fraction there is correct. So if you have either of those, you are good to go. And then our decimal, 0.4, and our percent, 40%. For number 3, our fraction here, 1 over 8. Our decimal, 0.125. Our percent, 12.5%, which if you rounded that to the nearest percent, then 13%. Either is correct, depending on if you rounded. For number 4, our fraction, 5 over 8. Our decimal, 0.625. Our percent, 62.5%, which rounds to 63% if you rounded to the nearest percent. For number 5, our fraction, 8 over 9. Our decimal, 0.8 repeating. Our percent, 88.8 repeating percent, which rounds to 89% if you rounded to the nearest percent. And lastly, number 6, our fraction, 2 over 9. Our decimal, 0.2 repeating. Our percent, 22.2 repeating percent, which rounds to 22% if you rounded to the nearest percent. So there you have it. There's how to calculate basic probability. I hope that helped. Thanks so much for watching. Until next time, peace.